66 million years ago, the Hell Creek Formation was a sprawling, humid ecosystem. It was a landscape of dense forests and winding rivers, supporting a massive diversity of life at the absolute peak of the Mesozoic era. Heavy-plated herbivores and towering apex predators dominated this environment. The fossil record suggests resources were abundant, with several major lineages reaching their largest sizes just as the period reached its end. For decades, the primary explanation for their disappearance was a slow decline. Many scientists argued that massive, prolonged volcanic eruptions in India were responsible, gradually shifting the climate over millions of years and wearing down global populations. But the geological record contains a different story. In rock layers found all over the world, there is a thin, dark band of clay that marks a total break in the history of life, separating the age of giants below from a world of small survivors above. In 1980, Luis and Walter Alvarez discovered that this specific clay layer is packed with a metal called iridium, reaching concentrations hundreds of times higher than the surrounding rock. Iridium is vanishingly rare in the Earth's crust, yet it is common in asteroids. This spike in the clay provided the first physical evidence for an extraterrestrial impact. The presence of this space dust globally indicates that the dinosaurs did not fade away through a slow volcanic decline. Instead, a sudden, violent catastrophe interrupted the Mesozoic and triggered a rapid transition into a new geological era. 0 hour began when an asteroid roughly 10 kilometers wide struck the shallow seas of the Yucatan Peninsula at Chicxulub, Mexico. The immediate consequences of that strike are preserved thousands of miles away in a fossil site in North Dakota called Tanis. Within minutes of the impact, massive water surges, triggered by seismic waves, rushed inland from the nearby seaway. This wall of water instantly buried entire river ecosystems, trapping fish alongside glass beads raining down from the atmosphere. Because it captures these impact beads, the Tanis site provides a unique snapshot of the environmental devastation occurring on the very day the asteroid hit. However, the kinetic energy of the blast and the initial surges only devastated the immediate continent. To kill off 3/4 of all life on the planet, the asteroid had to trigger a global climate collapse. In 2016, a scientific team began drilling into the crater's underwater peak ring to extract samples of the bedrock from the moment of impact. These drill cores showed that the asteroid struck a seabed composed of gypsum, a sulfate-rich rock that would prove more dangerous than the asteroid itself. The collision instantly vaporized the gypsum, ejecting trillions of tons of sulfur into the atmosphere, wrapping the planet in a reflective haze. This blackout blocked the sun for years, halting photosynthesis. Without primary producers, the global food chain collapsed from the bottom up. As the sulfur returned to Earth as acid rain, the oceans rapidly acidified. This chemical shift dissolved the shells of vital marine life, causing the extinction of species like the ammonites. While the initial strike leveled the region, it was this subsequent impact winter that systematically starved out the survivors and caused a global mass extinction. Ectotherms like crocodilians and sea turtles were able to endure long periods without food, allowing them to wait out the worst of the impact winter. A few small ground-dwelling avian dinosaurs also slipped through the filter, eventually radiating into all modern species of birds. But the most significant survivors for our own history were the small mammals. Their ability to burrow underground and scavenge on detritus allowed them to persist in a world that had become inhospitable to giants. As the atmosphere cleared, these survivors underwent massive adaptive radiation. Without dinosaurs, mammals diversified into forms we recognize today. This allowed marginalized groups to flourish, expanding into new habitats and evolving into the first primates. The loss of the dominant reptiles removed the biological constraints that had kept mammals small and hidden for over 100 million years. In the wake of the disaster, these survivors diversified into the lineages that would eventually produce our own species.